Welcome to the last lesson in this unit. We're talking about the most complicated structure that we've seen so far. They're called esters. And you remember when we talked about carboxylic acids, we said that those were some chain of carbons that would end with a COOH. Esters are one step different from that. An ester is the same carbon chain connected to a COO again, but then instead of an H here making it an acid, there's another chain of carbons. And so when we give the name for this thing, we're going to describe the two carbon chains, and it'll be understood that there's a COO in the middle, but we want to know what are the pieces on either side of it. Now, the workbook rules, the standard rules that we give you, are a little brain twisty because what they tell you to do is take the piece that contains the carboxylate, the COO. That would be this piece. And this is the second part of the ester's name. In this case, 1, 2, 3, 4, 5 carbons would normally make you think pentane, but because of the carboxylate group on it, we call this pentanoate. I usually pronounce this pentanoate. I just find that a little smoother to pronounce, but pentanoate is fine too. And before that, we put the name of the carbon chain on the other side of it. This is a single carbon, so you should be thinking methane, but when it's attached to something else, we call it a methyl group. And so the complete name for this ester would be methylpentanoate. Their way is second piece first, then first piece. The way that I remember this involves looking at doing the name in the proper order, and I look for the part that's single bonded to oxygen is the first part of the name. So I would read this, I'd see the O, single bond. Methyl is what I would write first, and then I look for the part connected to the double bond. That's my 5 carbons, and from that I would get pentanoate. Same name either way, but you can approach it either of those ways. If you find it uncomfortable to write the second part and then jump back, maybe try my way and see which one you're comfortable with. So, not surprisingly, we're going to get some pictures of esters and try our hand at naming them, and we're also going to get some names of esters and try our hand at drawing them. So, let's see how we manage that. Okay, so here are esters, and what identifies an ester is you'll see this COO structure, which we know is a carboxylate group, functional group, and there will be a carbon chain connected to one of the oxygens by a single bond, and there will be another carbon chain connected to the other oxygen by a double bond. So, if you do this one their way, like the workbook suggests, you will find the piece that contains the carboxylate group, this chunk, and you'll say, this has 2 carbons. 2 carbons is ethane, so in this case, it's ethanoate. Then you'll locate the other carbon chain, which is a single carbon, methane, only in this case it's a methyl group, and you'll write the name as methyl ethanoate. Or, the way I'd approach this one, you see the carboxylate, you find the carbon chain that's on the single oxygen, and you do that first. Single first, double second. So here you would say single bond is a methyl group. And on the double bond, we have 2 carbons, that's an ethyl group, or in this case, ethanoate. Same result, obviously. I don't think I'll do this every time, but try both approaches and see which one you find less annoying. Here we have, there's our carboxylate. On the single bond, we have a single carbon, so I'm going to say methyl. And on the double bond, we have 1, 2, 3, 4, 5 carbons, which would normally be pentane, but in this case, the ending gets changed to pentanoate. And last one, here we have our carboxylate. On the single bond, there are 2 carbons, which we would call ethane by itself, or in this case, an ethyl group. And on the double bond, we have 3 carbons in a chain. That would be propane, or in this case, propanoate. Or if you want to say propanoate, I have no way of stopping you. That's fine too. Okay. Let's see what adventures await us on the next page.